Quantum numbers are a set of 4 numbers that identify one specific electron versus all other electrons in the atom. So the first quantum number is just the energy level. So for our example here, the electron is in the 4p, so the energy level is 4. The second number is for the sublevel, and so because there are 4 different sublevels, S, P, D, or F, we have to assign a different number for each one. So if it's in a P, we're going to assign a 1. So 4 and 1 just means 4th level, P sublevel. And now we need to tell whether it's on the px, the py, or the pz orbital. Remember, their p's are sort of that figure 8 dumbbell-shaped orbital. And there's one on the x, one on the y, one on the z. And so we have to have 3 different numbers for those. And so these are the 3 numbers. In our example, the electron is in the px, so we're going to assign a -1. So now we've narrowed it down to the 2 electrons that could possibly be in that orbital and sublevel, the px in the 4th level. And now we need to say whether this is the electron that spins up or down. And so on your spin quantum number, if the electron spins up, we're going to assign a +1/2. If it spins down, we'll have the opposite, -1/2. And so in this case, it's +1/2. So no 2 electrons can ever have the same set of 4 quantum numbers. Even the electron that would partner with this electron would have the first 3 numbers the same, but because it spins down, its last spin quantum number would be -1/2. If you have an electron in an s orbital, we're just going to assign a 0. A d, there are 10 electrons in the d sublevels, and so that means there's 2 electrons in each shape, so there are 5 different shapes, and so we need 5 different numbers. And you'll notice the second number for d is a 2, and this is -2 to +2. For f's, there are 14 electrons, so we need 7 different shapes, and so we just go from -3 to +3, negative to positive, whatever the second number was. So a 7s, the energy level is a 7. If it's an s for the sublevel, we're going to assign a 0. The third number, there's no choice. There's not, more than one shape you can have within an s sublevel, so we're just going to assign a 0. And if it's spinning up, a 1/2. In this 3p example, 3 is the energy level, p is the sublevel, so we're going to assign a 1. It's in that center py shape in the middle, the second of the 3 blanks, and so we're going to assign a 0. And then now we need to say which of these 2 electrons this one we're looking at is. It's the one spinning down, so we say -1/2. In this example, it's a 4d electron, so its energy level is 4. D orbital would be a 2. It's in this shape, and so we're going to assign a +2, and it's the one spinning up, so 1/2. So from the first 2 quantum numbers, you can actually identify an orbital. If n equals 4, that's 4th level. If L equals 2, that's a p. So n equals 4, L equals 1, or if they just write 4, 1 for quantum numbers, that indicates a 4p. If you have energy level 3, that's 3rd level. L equal, or the second quantum number is 0, that's an s, and so that would be the 3s orbital.